So our next presentation, we have two speakers who will share the talk, which is entitled Changing a 4 to a 5, the detection of a forged date on a Lincoln pardon. Our first speaker will be Kathy Ludwig, who is a senior conservator who has been with the National Archives for the past 16 years, and she works closely with our textual holdings and archives too. She was in the first graduating class of conservators from the Program for Library and Archives Conservation at Columbia University in 1984. Prior to working at the archives, Kathy served as a conservator at the Minnesota Historical Society in St. Paul, Minnesota. Our second speaker on this topic is Jennifer Herrmann. And as Jennifer has said, while she went to school for analytical chemistry, she was thrilled to find a career in conservation science and enjoys being part of the Conservation Research and Testing Lab. She has been at the archives for 5 years and still finds the work varied and interesting. That's good news. She is especially happy when she can help other NARA and cultural heritage professionals answer questions that protect our holdings, whether by running an XRF or FTIR analysis, by reviewing materials that are safe for use in exhibit cases, or writing specifications for holdings maintenance materials that will create a good environment for long-term preservation goals. So I think Kathy will speak first, followed by Jennifer.
Good morning, everyone, and thank you for coming to hear Jennifer Herrmann and I tell you about our experience with a very interesting document in our holdings. It is the 1864 Lincoln pardon of Patrick Murphy that was originally dated 1 day and 1 year before Abraham Lincoln was assassinated. About 2 years ago, on January 25th, the Archivist of the United States, David Ferriero, announced that a gentleman by the name of Thomas Lowry, a longtime Lincoln researcher here at the archives, he's from Woodbridge, Virginia, confessed to altering the Abraham Lincoln presidential pardon back in 1998. This was a permanent record of the National Archives. This pardon for Patrick Murphy was a Civil War soldier in the Union Army who was court-martialed for desertion and was sentenced to be shot to death. And Lincoln pardoned him. Before I go any further, I'd like to share with you a brief YouTube video that was made on this topic, and it will sort of answer a lot of your questions of who, what, when, and how. And then I'll continue on with telling you our experience that Jennifer and I had with examining this document. This video is only just a little over 2 minutes in length.
When this document came to light in the late 1990s, there was a write-up in some of the local newspapers and got national attention. It's a pardon by Abraham Lincoln of a Union soldier sentenced to death by court-martial. It was April 14th, 1865, which is the day that President Lincoln went to Ford's Theater later that night and then was shot by John Wilkes Booth.
It had been identified by a researcher, Thomas Lowry, and his wife. He made this into a major story, that here he found this document that he believes is one of the last things signed by the President of the United States.
This kind of put him into the Lincoln expert world, where he then published a number of books. I started kind of using this document frequently on some of the VIP tours that I would give at the National Archives. And the more I used it, the date, it started to look a little hinky to me after a while. The ink on the 5 was a little bit darker than the rest of the date, and it looked like there was almost like a ghost image or something underneath it, that it looked like it had been written over another number.
Trevor went to the most authoritative source available, Basler's collected works of Abraham Lincoln.
Roy Basler has transcribed Lincoln's endorsement, but it's not April 14th, 1865. He has it as April 14th, 1864. Then that's when I presented what I had found to the Inspector General's office at the National Archives.
I immediately said to him, there's one person I believe that would have done this, and that's Thomas Lowry. Myself and one of the investigators paid a visit to Mr. Lowry's residence. He indicated that he snuck a pen in, it was a Pelican pen, and that he marked the document. He had changed the date for the simple reason of just getting some notoriety.
We rely on primary sources and primary documents as the foundation of our profession. It's very galling and upsetting to me as a trained historian that someone would change a document to make it more historically significant than it actually is.
Because of the statute of limitation, he will not be criminally prosecuted. But however, he will be banned from the National Archives.
Civil War magazines, they still mention this as, this is one of the last things that Lincoln did before he went to Ford's Theater. It's a very good tale that people like to tell, and they've been telling it the last 12 years. And unfortunately, that story ends up being untrue.
Here's the document that they were describing, and this is the letter to the Judge Advocate General requesting the pardon for Patrick Murphy, and then to the left of the document is the message written by President Lincoln pardoning the soldier, and the message says, "This man is pardoned and hereby ordered to be discharged from the service, dated April 14th, 1865, A. Lincoln." So this is what the document looks like. The document was brought to the Conservation Lab, not for us to determine whether it was a forgery. It had already been determined. But the document came with the question, can we reverse this forged date? Is there anything that we can do about it? So we were given the document to examine just to see how the forgery was made and if there was any possibility of reversing this forged number. So what we did first was look at the document. The way we do with a lot of our documents that come into the Conservation Lab, we inspect them visually. We did no testing that involved any sampling, and this was a non-invasive kind of examination where no solutions or anything like that were applied to the document. We simply looked at it and tried to gain as much information as we can. And we have some wonderful tools in the Conservation Lab that allow us to examine things very carefully and see things with microscopic tools that we can't see with our unaided eye. So here I used what we call our stereo zoom microscope, which is a microscope that allows us to use both eyes to look through, unlike a standard microscope, and it gives us a three-dimensional image, unlike a normal microscope where it's two-dimensional. So it's great for seeing texture, the typography, that sort of thing in a document. We also have the ability with this particular microscope to go from 6 to 50 times magnification just by simply dialing the knob on the side so we can stay focused in one area. We also have here a lamp. It's called a fiber optic lamp that we can adjust and shine the light on the document at various angles. And this accentuates texture and allows us to see a lot of information that we would not be able to see with just general daylight. The document was illuminated with fiber optic lights, and this is what fiber optics is. You're probably very familiar with it. It's in a lot of our technology today. But basically, the light source is a halogen lamp, and then the light beams are transmitted through glass rods and then come out through the end of the lamp here. And it is a cool source of light without any UV. So we can keep this intense light on an area of the document for an extended period of time without adding any heat or any damaging radiation to the document. This is a setup that was used to examine the document where a camera was put on the microscope, and then the camera is attached to a monitor over here. And that allows us to see a larger image of what the camera is actually seeing through the lens of the microscope. And I'm focusing here on a piece of paper where I've printed some periods, like the end of a sentence. And I use 12-point type. So this shows you how small the period is on a piece of paper. But when it's magnified 50 times, this is what it looks like under the microscope. And you can see that the texture of the fibers of the paper, you can see how diffused that toner is on the paper. It's not a hard line. In fact, you can even see some particles of the toner. So it really gives us a lot of information that we could not obtain without magnification. Now here we have the date, the questionable date, and you can see there's something a little bit fishy about it right off. I mean, that 5 looks different, and there's some sort of scratchy debris marks around the 5. So then we looked at it differently under a couple different forms of light. First, we looked at it under the microscope under high magnification, and here we have it at 50 times its original size, and you can see that, number one, the color is different on the 5 compared to the 186. You can see that the paper is abraded and scratched underneath and around the 5, and you can even see that there's indentation, what I call tine marks, from the pen, the fountain pen that was used to write this 5. And this is what I mean by tine marks. This is the nib on a fountain pen. It's metal, and when you press down, it makes an impression in the paper. And we don't see those tine marks, I'll go back, in that 186. So we're right off the bat, we think, well, here, this 5 was written with a different pen. The ink looks different under magnification. Now here's the document, the front and the back of it. And to the right here on the back of the document, I've circled an area in the red circle, and that's the back of that 5. And you can see where the ink has penetrated through the paper in a way that the other ink hasn't. So the paper is probably thinner there, and because of the abrasion on the paper, and the ink has struck through to the back of the paper. This is what it looks like in close-up. That's the 5. And you can see there's just a bare halo of the 8-6 next to it to the right. Here we're looking at the document with transmitted light. That allows us to see through the paper, and we can see areas of paper that have been thinned or inclusions in the paper. Again, it's using a fiber optic light sheet, which is, again, is a cool source of light, and we can feel safe about exposing the document to that for some extended periods of time. So here's a picture using transmitted light, and I think you can see in the area around the 5 that it's much lighter. More light is being transmitted through that area because it's been thinned as a result of the scraping. And the 5 looks like it's been applied with much heavier ink, so it does look different from the 186. The next thing we did was we looked at the document using an ultraviolet lamp, and this is a tool that's commonly used during examinations because ultraviolet light or radiation tends to be absorbed or fluoresce for various substances and gives us an idea of what a particular material might be because there are characteristic colors and looks to these materials under ultraviolet. And when I exposed our document here to the ultraviolet lamp, the ink, which we believe is to be iron-containing iron gall ink, which is a very common ink used at the time, absorbed that light, and we can see it's heavily absorbed in the 5, and also the area around where it was scraped and abraded, I believe there's particles from the 4 that was scraped away and are now embedded into the paper and are much more visible with the UV lamp as opposed to just normal daylight. So I think by just using some very simple techniques to look at this document with a microscope and a couple different light sources, we can determine that that 5 was abraded. The area around it has been braided. It's scratched. We can see the tine marks on the pen, which we don't see in the adjacent numbers. The paper is much thinner around and underneath that 5, and that 5 the ink itself responds very differently to UV light, and it absorbs that light and shows us the particles in this area that aren't quite as visible now just in normal daylight. So that's the information we were able to determine by just simple examination, and I'm going to turn the podium now over to Jennifer, and she's going to talk about some analytical techniques that were used to characterize the ink and confirm our suspicion that this 5 is different from the 186. Jennifer?
Kathy gave a very thorough visual examination and was able to find all of these differences in looking at it. So then we wanted to see if we could find some chemical differences too. So we used X-ray fluorescence spectroscopy. X-ray fluorescence spectroscopy is one of the first high-tech scientific instruments that's been applied to the cultural heritage field. It's been used to examine archaeological artifacts as well as paint in Grandmaster paintings. And so we wanted to look at our line of ink. Did I skip a slide? No. I first want to give you a little bit of background on XRF so that you'll understand when you see the analysis that we ran. In XRF, we use a rhodium source to emit radiation that knocks an electron out of the center closest orbital of an atom. Once that happens, the atom is no longer happy, and an electron from a higher energy orbital will fall in to take its place, and then a cascade will occur, because if it falls from this line, then a higher energy electron will fall into its place until the lowest energy levels are reached in the atom. So here we can see the X-ray coming in, ejecting an electron, and then one of these electrons will fall into place. If an electron that makes these red lines that I'm showing falls into place, we'll see a pattern here. If it's a blue line, it will be here, which we're bombarding it with X-rays, so there are multiple chances for many different atoms to lose X-rays, or to lose the electron. When the electron is lost, then this energy is released as it falls, as the replacement electron falls into place, and that's what we're actually analyzing, and it's a type of fluorescence. Oh, the example was of a silver object, so there was really only the source peaks and the silver in that spectrum, so it was much simpler than the ones we're going to look at now. We used a Bruker Artex XRF with a rhodium X-ray source operating at its highest energy level so that we'd be able to see a broad range of elements. We also used a helium flush so that we could see lower elements as well. However, the XRF cannot see organic materials, so it's really very good for metals and heavier elements. So now this is a comparison of analyzing this spot on Abraham Lincoln's signature along with an organic pen that we just wrote on a different piece of paper to compare, so that we could see that Kathy had found many differences in how it visually looked. We were hoping that it would also look chemically different, because that could have made it easier to potentially remove or not. And so the green trace here is Abraham Lincoln's ink, and we can see a large peak for iron, a peak for sulfur, and there's also potassium. There's calcium, which could be in the paper or the ink potentially, and then these are from the rhodium source. The red line we can see really doesn't have anything there, and because it's organic, we would expect that. So we can tell that these are very different inks. We compared a couple different places on the known Lincoln ink. So this is Lincoln's signature in green compared to the 8 in the date, and we can see that they overlay perfectly. So we know we should expect that. Next, we compared, well, in this comparison, as I said, we did run more comparisons than I'm showing you. In this comparison, though, we are looking at the spectrum of the 8 compared with the spectrum of the 5. Hopefully, everybody can see that there are large differences here and also in the sulfur, so that the iron signal is extremely different. However, we're picking up all the same elements. So there's iron, there's sulfur, there's potassium, which means that Lowry, when he changed this, he knew that Lincoln used iron gall ink, and so he used iron gall ink too. So from this analysis, we know that it's the same type of ink, but we can still say definitively that it was not the ink that Lincoln used, because the ratio of iron to sulfur is 4 times in the Lowry ink, but in Lincoln's ink, there's only 1.5 times more iron than sulfur. So this just shows a couple other spots where we analyzed. And it's interesting to point out that all of the patterns from like Lincoln's signature, the date, and even this ghost image of the 4 that was talked about by both Kathy and Trevor Plant, all give the same peak pattern for the XRF spectrum, while the 5 was very different. However, because of it being chemically similar, there's no way to reverse this damage that's been done. And so our report stays with the object, and so when people access this, researchers in the future, they will still see the 5 there, but our report and other reports by the Inspector General's office will be accompanying it so that in the future somebody who accesses this will know that it was supposed to be a 4 and not a 5. So Kathy and I want to thank you for listening and thank all of our colleagues.
Thank you both. Are there any questions here in the room? And Dina, do you want to check to see if we have any from the web? Yes, sir. I'm not sure that everyone was able to hear the answer. There is a microphone that we have on the side. Do you want to give a really brief reprise of that? Are there other questions while Ken gets the mic? We all, of course, think it was a horrible, horrible crime, despite what the legal system might say or do.
Yeah, the question had to do with what the punishment is if you damage or mutilate documents. It's in Title 18, U.S. Code, Crimes and Punishment, paragraph 101. You have to drill down a little bit. You'll see 2 subsections. The first one deals with the general public, damaging, mutilating, losing, stealing records. The second paragraph, subparagraph B, deals with people who actually are the custodians of the records, and they are punished. And the punishment, I can't remember if it's 2 or 3 years. You can also be fined. And for the people who work in the federal government, you'll lose reemployment rights to the federal government. You'll never be able to be employed at the federal government again. That's if it goes to court.
Thank you, Ken. Was there another question in the room? Henry?
What's the end of it? Are we keep the 5 forever, or what do we do with it? We put some note on document?
As I stated at the end of the talk, since it couldn't be reversed, we're just keeping our report, and along with copies of any of the Inspector General reports, and that they will remain with the document so that it will be clear to any researchers who will access this in the future that the 4 has been changed to a 5, but we cannot change it back.
So the unhappy end of that tale is that some damage simply cannot be reversed. I think that's it, unless there is a final quick question. And I guess nothing from our colleagues from afar. Thank you, Kathy and Jennifer. That was great.